I want you to know what's going on, but I also want you to know why it's going on. So all that being said, let's go ahead and get started. So this is the next video in a series of videos I have done on the binomial distribution. So in those previous videos, I really dissected what the binomial distribution is from the ground up. So this video is more of a real-world example of how we can use it. So we're going to be using a real-world problem, using real data that I got off the internet today as of the recording of this video, and the binomial distribution will allow us to answer some pretty complex questions about our data. So in this one, we're going to look at the percentage of internet users that use the Mac OS X operating system. So we're going to develop a distribution and then answer several questions about it. So let's go ahead and get started. So here is our question. According to recent data collected by netmarketshare.com, 7.3% of internet users are using some version of Mac OS X. Now they can tell what operating system you're using and what browser you're using, because when you go to a website, it actually sends that information, unless you have something on your computer that can block that. But most people don't, so they can at least learn your computer, operating system, and your browser. So based on a random sample of 25 internet users for a class project, we are interested in the following. So for a class project, you're going to randomly select 25 internet users that are a good cross-section of the internet user population, and they're going to answer some following questions. The first thing we're going to do is we're going to graph the binomial distribution in Excel using the information we have above. So we have 25 internet users in our sample. We have a success probability of 7.3% or 0.073 in decimal form. So we're going to use that information to make a binomial distribution graph in Excel. We're also interested in the binomial distribution's mean and standard deviation. And then we're going to answer some questions about certain segments of the distribution. Like, what is the probability that exactly 3 users out of our 25 are using OS X? What is the probability that more than 5 users are using OS X in our 25-person sample? What is the probability that 0 users are using OS X? So we have a sample of 25 people. What is the probability that none of them are using OS X? And finally, what is the probability that between 2 and 5 users are using OS X? So we're going to look at a very slim segment of our distribution and find that probability. Now to do this, we're going to actually be using the graph we make in Excel. So whenever we answer a question in this list, we're actually going to physically tie it to our graph that we make in Excel, so you can see exactly what's going on in the distribution. Now, of course, to do that, we have to go into Excel and make our graph. So let's go ahead and do that right now, and then we'll come back here and answer these questions. Okay, so let's go ahead and graph our binomial distribution here in Excel. Now I've gone ahead and filled in some basic information from our problem. That way you don't have to look at me typing a bunch of stuff in. So at the top we have n equals 25, that's our sample size. We have p equals 0.073, that's our probability of success. In this case, a success is a user is using OS X. And q is our probability of failure. That's just 1 minus p. Now on the left-hand column we have the outcome, and in the second column we have the probability. So remember, in this problem we can have an outcome where 0 users are using OS X all the way up to all 25 users in our sample are using OS X. So the outcome here is simply 0 up to 25. So 0, 1, etc. Now I'm going to use the autofill feature in Excel. So if I hold over the little cross there appears, if I hold Control, at least on the PC, and drag down, it will fill in all the way up to 25 for me. There we go. So there are our 25 outcomes. So 0 people could use OSX out of 25, 8 people could use OSX out of 25, etc. So now we need to find the probability for each outcome. And we're going to do that by using the insert function command in Excel. So we'll go up here to the little f of x at the top of the bar here. Click that. And we want the binomial distribution function. So we're going to type in binomial. So binomial, we'll hit go, and you'll see several come up. The one we're interested in is the binom period dist. Now if you're using a previous version of Excel, it might just say the binom dist. But for 2010, Excel 2010, we're going to use the binom dist function. So we'll highlight that one and click OK. Now, this requires 4 arguments, and that's why we input the data ahead of time so we can just select them. We're not going to do them in exactly the same order they're listed, but you'll see sort of how this works. So let's get on to trials. This is the same thing as our sample size in this case, so trials. Remember, n is 25. So we want to select that by putting the cursor there. Then we'll go up to where the 25 is in B1. We'll click that. Now I'm also going to hit the F4 key to make that cell absolute. And that's a common thing you want to do when you want that cell to remain as you drag functions that will keep it steady. Okay, now let's talk about the probability. Well, we know our probability of success is the 0.073. So we'll go up there and click that. And we'll also hit F4 to keep that absolute. The number is going to be our outcome. So the outcome column, as it goes down, will be our number. So we're starting at 0, so I'll go over and click the 0. That will put A4 in there. Now I do not want to make this absolute, because if I make this absolute, I cannot drag down the probability column. So I will leave this as it is. Now in the cumulative field, this is a true or false. If we put true in, it's going to give us the cumulative probability. And in this problem, we don't want that. So we're going to put in false. And what that does, that will give us the probability for each specific outcome. So we have our trials, it's in B1, our probability is D1. I'm assuming yours looks like this. Our number is actually going to come from the outcome column, starting with A4, and cumulative is false. So we'll go ahead and click OK. And there's our probability. So what we want to do is we want the probability for each outcome down that column. So we'll just click and drag all the way down to 25. And those are our probabilities. So we have, with each outcome, 0 through 25, we have an associated probability. Now we want to graph that. So the way I do these, I'm going to go ahead and select both columns. I'm going to go up to Insert, and believe it or not, I'm going to pick a scatter. Okay, a scatter. That's because a scatter is two-dimensional, and it makes these much easier to do. So we'll go ahead and click Scatter. And here is our graph. Now it doesn't look a whole lot right now, but we're going to make some changes to it. Now I know that this is probability, so I'm going to take the probability off and delete that there in the legend. And I'm going to change this to Mac OS X user probability. I'm going to tell myself that N equals 25 and P equals 0.073. Something like that. As long as it gets the point across. Okay? Now I'm going to do some changes to my graph. What I'm going to do is I'm going to click or right click on one of the data points. I'm going to select Change Series Chart Type. So I'll select that. And I'm going to change those dots, those points, into columns. So I will just select the top left column graph format. I'll click OK, and that gives me a nice bar chart. Now, one thing I do want to do is I'll make this a little bit bigger so we can see here. There we go. Now, one thing I like to do is get rid of the space between my bars. So I want to right click on one of my bars, go back to Format Data Series, and this comes up where it says gap width. I'm going to move it down to 0. But then to tell the bars apart, I'm going to go to Border Color, select Solid Line, then I make mine black. The border is black. Click Close, and I'll click off of that. And there we go. So now we have a nice, really nice and clean binomial distribution graph that we can then copy and then take back into our presentation and work with. Let's go ahead and continue. Okay, so here is the graph we came up with in Excel. So along the bottom, you can see we have 0 through 25. Those are our 25 internet users in our sample. On the left-hand side, we have probability. So the height of the bar is the probability of that outcome. So this might look a little different than other distributions that you've seen. You're probably used to the normal distribution where it's sort of a bell shape in the middle and it goes out on the ends. But this one obviously looks a little bit different than that. So how does it get its shape? Where does it actually come from? Well, we talked about what the axes mean, so that's pretty self-explanatory. But if you notice, the probability of our success was only 7.3%, or 0.073. Because our probability of success is so low, we expect the vast majority of our probabilities in our distribution to be smashed down towards the low end. So, we know that 7.3% of our users are using Mac OS X. Now, on the right-hand region, the probability is very small for these outcomes. So we have our 25-person sample. The probability that 18 of them are using Mac OS X is almost 0. It's not exactly 0, but it's a very, very, very small number. Same thing for 22. 22 out of 25 people using Mac OS X is almost 0. It's a very small number. And that should make sense because only 7.3% of users are using OS X. So if we had 20 people using OS X in our sample, well, that's 80% of our sample. But out in the world, only 7.3% of users are using it. That's why the probability of that 20 happening is so small. But on the other hand, we have a lot of probability on the left-hand side of our distribution. The probability is much higher. And of course, that's because the probability of success is 0.073 or 7.3%. So about 7% of 25 is down in this range. So think about it. 10% of 25 is 2.5, right? So a little bit less than that would be over even further to the left. And that's why we have so much probability sort of crunched in the left-hand side of this graph. So if you kind of understand how the graph gets its shape, where it comes from, how the height of the bars is related to our sample size or trials, which is 25, and the probability, then you really have a good understanding of the binomial distribution. Now my question for you is, what would this graph look like if P wasn't 0.073, but was, say, 0.5? Where would the lump of probability be in our graph if P was 0.5? Well, it would be right in the middle. So our distribution would be like in the middle. It would look almost like a bell-shaped distribution if P was 0.5. So you can see how our success probability up there at the top influences where the majority or the vast majority of our probability is. Okay, so let's go ahead and answer some questions about our distribution. So the first thing we asked is, what is the mean and standard deviation? And I did this in a previous video, so we'll walk through it pretty quickly. So remember, N is the number of trials, and in this case it's not calls, it's users. Probability of success in any trial, and then Q is 1 minus P. So forget the word calls there, that's my mistake. So the mean is N times P. Standard deviation is N times P times Q, and take the square root of that. So in this case, N is 25 and P is 0.073. So multiply those together, and the mean for this binomial distribution is 1.825. The standard deviation is just 25 times 0.073 times 0.927. Take the square root of all that, and our standard deviation is 1.3. So again, we covered this in a previous video. It's pretty easy to do these. Just multiplication, and in the case of the right-hand side, take the square root. So let's go back to our distribution that we did in Excel. We have a nice graph to work with. So the arrow up there represents the approximate location of our mean. And look where it is relative to the bars. That should kind of make sense. The mean is somewhere in there, it's like 1.8 or so, between 1 and 2. Now our standard deviation was 1.3. And if you remember, we're always interested, or most often interested, in the area of our probability that is either 3 standard deviations above or 3 standard deviations below our mean. So let's look at 3 standard deviations above the mean. Well, it's approximately this region. Now what about 3 standard deviations below? It's this region. So you can see that the vast majority of all the probability in this distribution is within 3 standard deviations of our mean, plus 3 or minus 3. And that's an important concept in a lot of later statistics that we do when we talk about the normal distribution. But I just wanted you to see how this lines up with our graph. So let's talk about the TI-83 real quick. Again, I went through this in a previous video, but I want you to know where the command is. So the first command we're looking for is the exact binomial probability. So for example, this is a graph I used in a previous video and looking at sales, and we're interested in the probability of exactly 7 sales. So where that green bar is. So we want to know the exact probability of 7 sales. Now look at the graph. About what does it look to be? Well, we go up, it looks to be about 0.25. The probability of exactly 7 sales is about 0.25. But how do we do that in the TI-83? We're going to use a function in the calculator called BINOMPDF. So we're looking for an exact probability, and it requires 3 inputs. N is the number of trials, which in our case is 25. P is the probability of success, which in our case is 0.073. And X is the exact probability we're looking for. Okay? So you find this, you press the second button and then the VARs button to access the distribution menu. You'll scroll down and you'll find BINOMPDF, and you press Enter. And then we would go ahead and enter our data. So I went ahead and used the data on this graph. So in this case, our N was 10, our P was 0.75, and the exact probability we want was 7. So we input that into the calculator, and we hit Enter, and we get 0.25. So that's what we expect. Remember, we said the 7 bar goes up to 0.25, and it seems to be exact. We couldn't be exactly sure. But when we did it in the calculator, we found out that it is exactly 0.25. So using the TI-83 at least, and I'm sure it's the same in TI-84s and things like that, that this is the command we use to find the exact probability of one outcome. In this case, we used the 7. Now, there's another thing we can do called the cumulative probability in the TI-83. So if you look at this graph now, we're not interested in just the 7. We're interested in everything up to and including 7. So how do we do that? Well, we use a very similar function in the calculator. It's just binom CDF, and that's for cumulative density, I would assume, or cumulative distribution. And it inputs the same three arguments. So number of trials, probability of success, and probability of the upper boundary. So in this case, 7 is our upper boundary, and we're interested in everything leading up to it. So again, we go to the same menus, enter the same inputs, but this time we get 0.747. And that's the cumulative probability all the way up to and including 7. So if we added the heights of all the bars there in the green, it would come out to be 0.474. So that's the difference between exact probability for any given outcome and then the cumulative probability for everything up to and including that upper boundary. So we're going to need both of those to answer our questions. So here's our first question. The probability that exactly 3 users are using OSX. So in the calculator, we use the binom PDF. Remember, that's the exact probability. N is 25, P is 0.073, and X was 3, because we're interested in the probability at 3. Now, before we actually figure out the answer to this, let's look at the bar over here. About what should we expect it to be? If our graph is correct, the ballpark figure for our answer should be about 0.16, 0.17, somewhere in there, because that's the height, approximate height of our bar. So we should use some common sense here to know whether or not our answer is correct. And good. So when we put that in the calculator, we get 0.167. So the probability, or the height of that green bar, is 0.167. So how does this relate to the real world? So we go out and find 25 internet users that are representative of the overall internet user population, and the probability that 3 out of that 25 is using OSX is 0.167 or 16.7%. So we found the exact probability of 3 users out of the 25 using OSX. Okay, now how about the probability that more than 5 users are using OSX? So it might be hard to see depending on what you're looking at this on, but down below, everything that's 6 or higher, I colored in green, because that's what we're interested in. We're interested in everything that is 6 or higher. So, how are we going to figure that out? Well, remember, the probability of the entire graph is 1. So all the probabilities have to add up to 1. Now, if we chop off or subtract out everything that's there in the orange, which is below 6, then we can find out the probability of everything 6 or above. So what we do is we take 1 minus the cumulative distribution, or the cumulative probability, up to 5. So 1 minus 25, comma 0.073, comma 5 in our function in our calculator. So it's 1 minus the orange part. That'll give us the green part. And when we do that, we have 0.00028. And that should make sense because there's not much probability in that green part. It should be a very, very small number. And that is the case. So how does this relate to the real world? If we go out and pick our 25 people, probability that 6 or more are using OSX is 0.00028. So that is 0.028%. Very small. And that should make sense based on our graph. Now, what's the probability that exactly 0 users are using OSX? So now we're interested in the green bar over on the left. That's 0. So we go ahead and put this into our calculator. And again, it's the binom PDF, and that is 25.073, 0. That'll give us the height, or the probability, of that green bar. Now, what do we expect it to be? What should it be close to? Well, it should be close to 0.15. And it is. It's exactly 0.15. So the height and the probability, of course, are the same. So that's a probability of 0 users. And again, in the real world, if we pick 25 people and we ask them what operating system they're using, there's a 15% chance that none of them will be using OS X. Okay, now what about the probability that between 2 and 5 users, and we use inclusive there because we are counting or interested in 2 and 5 on the ends, are using Mac OS X. So look at our graph here. I've kind of put in green what we're interested in. We want to know the probability of 2 users, 3 users, 4 users, or 5 users out of the 25 using OS X. So think about it. How are we going to do that? So we're interested in between 2 and 5, but inclusive of 2 and 5. So if we find out the distribution up to 5, and then we subtract out, or kind of chop off, 0 and 1, that'll give us the 2, 3, 4, 5. So in the calculator, we do the 5 first. So binom CDF, 25, 0.073, 5. That will give us the cumulative probability up to 5. Then we'll subtract out everything up to 1. So binom CDF, 25, 0.073, 1. That'll subtract out the 0 and 1 bars. So when we do that, we have 0.992 minus 0.446, and that is 0.546. So if we add up the height of all those green bars, we will have 0.546. Okay, so back to our original problem. Remember, we sampled 25 internet users, and we're interested in the following. We did our graph in Excel. The binomial distribution's mean and standard deviation. So the mean was 0.1825. Well, what does that mean? Well, if we went out and we selected a group of 25, we figured out how many are using OS X, and we wrote that down. Then we go out and select 25 other people. We see how many are using OS X, we write that down. Then we do it again and again and again and again. So different samples of 25 people. Each time we write down how many are using OS X. Well, if we averaged those together, we would expect it to be around 1.825. All those samples. Now the standard deviation was 1.3. The probability that exactly 3 users used OS X is 0.167. The probability that more than 5 are using OS X is 0.00028. Very small number, and again, that should make sense, because up above, only 7.3% of users are using OS X, according to our data. So the probability that 5 or more people out of the 25, which is 20% or higher, is very small. The probability that 0 users are using OS X is 0.15, and that's actually fairly high, and that should make sense, because such a low percentage of users are using OS X, the probability that no one in our 25-person sample was using it is fairly decent. In this case, 15%. And that would not be an out-of-ordinary result. That's more than what we'd expect, because the percentage of people using it is so low. And the probability that between 2 and 5 users are using it is 0.546. Okay, so that is our whirlwind tour using a real-world problem, using real data that I pulled offline today as of the making of this video, and we went into Excel, made the distribution, then we used actually our graph to answer questions visually and using a calculator to find out different pieces of information about our distribution. So we found out individual outcome probabilities. We kind of sliced it up in the different sections and found out the probabilities over ranges and things of that nature. And that's exactly what these problems are like. So if you have these in class, this is exactly what's going to happen. Problems like this are often used in quality control settings. And the next video I do will actually be like this one, but it will be in a quality control setting, like you might do maybe like a Six Sigma thing or some other type of total quality management or something